We're gonna be safe and sound tonight.
Hello, so I saw this SpaceX Master Race post about this tweet regarding Starlink satellites and how much low Earth orbit they take up, and I was wondering what is the actual numbers, because I have no idea. I can't fathom how large space is, so I have to calculate it to figure it out. And math's fun, I'll do some math. So here is my work. You can check my work to harass me if I'm wrong. Earth's radius, looked it up. Starlink low Earth orbit band, looked up the difference. You have to take the difference to get the total area. We're taking the cross-sectional area of this orbit, this diameter, instead of the volume. So we'll get to that later. This is the Starlink max collision area, mostly the solar array. Here's this is the source. That's the source for my Starlink orbital data. Then we just divide by 1,000,000 to get square kilometers, because it just makes things easier for us. The polar inclination of the Starlink orbit, you take the sine of 53 degrees, and it covers 80% of the total 360 degrees. This is our volume, which I calculated because I thought I was going to use it, and then I didn't use it. So this is our cross-sectional area, which I mentioned earlier. This is the diameter. So you're taking the diameter using the radius, and then I just took the average of 545 because it's close enough. And then you add that together. So this is 545 plus the Earth's radius. Then you times by 2 to get the diameter, times by 3.14 pi to get the total circumference. And then you multiply by 80% because you're not counting the... Wait, what is this one? 52. Oh, okay. Then you're adding the thickness to the circumference. So you're getting a cross-sectional area here. That thickness is the width. Like, imagine you're taking this line and you're straightening it out, and then you want to make a rectangle, so you're timesing it by the width. So this is the length, which is the circumference, and then the width is your 10-kilometer band. And then you're multiplying by 80% because it's not going all the way around the Earth. And then you're actually dividing by 2 because you only want this half of the Earth. See how the Earth makes 2 halves? So your cross-sectional area, you have to divide by 2 again. So anyway, after that whole long explanation, the end result is 173,500 square kilometers. Now, that doesn't sound like much, but this is how many square kilometers our Starlink satellite is. So you have to divide by 0.000003, and the Starlink satellite turns out to be 1/5.8 billion of that cross-sectional area of the Earth. Now, we're not done yet. We're not done. It's much higher than 1/5.8 billionth. In order to have a collision, 2 Starlink satellites need to be in that exact 3-dimensional space at the exact same time. So the probability of that happening randomly at the same time in the same place, you have to square them for our chance of collision, which works out to be 33 million trillion. 1/33 million trillion is the chance of 2 Starlink satellites randomly running into each other in low Earth orbit. So profoundly small. I thought it was going to be like 1 in 10,000 but it turns out to be much, much higher than I anticipated.